This video is all about finding the inverse of sine, cosine, and tan using log table. So now let's begin. The first question is sine x equal to minus 0.23237. Now, but let sine theta is equal to 0.237 because we don't have negative values in the table. So now the negative value, we are going to sort it out with this quadrant. Now at the first quadrant, all the trigonometry functions is positive, as in the sine, the cosine, and tan. They are all positive here. Now in the second quadrant, it's only sine that is positive. In the third quadrant, it's only tan. In the fourth quadrant, it's only cos. No, so with that understanding, now this question now means since sine is positive here and here and is a sine function, so that means this angle will fall under the third and the fourth quadrant. So for us to be able to find this particular problem, to find the solution, now since it falls here, let's treat this first one, the one of the third quadrant first. Now this is the reference angle. This is the acute angle from the x-axis, which we assume to be theta. From here to here is theta. Then this reference angle, which is this, is 180 plus theta. Now, we needed to find the theta when it is positive value. When it's positive, which is when it is positive on the first quadrant, which is theta. So now the theta will now be the sine inverse of 0.237. So now let's now look at the table. When we get the theta, we can now find the angle at the third quadrant. So the theta we are looking for now is this theta on the first quadrant, which is theta, and this theta is equal to this angle here. So we're looking for this angle here, which is also equal to this angle. Now, and from here to here is equal to 180 plus this angle here. So that, which is this. Now we needed to find this angle. So if we could be able to get this angle, then the solution is near. Now let's go to the table, the log table. We will now look at the sine table. Let me see. The sine table. Okay. Now we're going to look at inside the sine table, inside this region, we're going to look for value that is close to 0.237. Now you have here as 0.2079. So but okay, look at this. You have 0.225. So let's go 225. So 227. Is this sign here? Okay, we're looking for 237. So now this is 0.225, 226. This is 230023. So okay, now this is 2368. 2368. So the number falls between this number and falls between 2368 and 238. 2.85. So now that means we work with the smallest one, which is, since it falls in between these two lines, we're going to use the mean difference. Had it been we got it exactly, we're not going to go here. Now, this is 13 degree. Now we're going to use minutes since it falls within the mean difference. So now we have 2368, which is 42 minutes. 13 degree, 42 minutes. That is here. And then we needed to add some value to it to get to Let me see. You have now we have this, which is 0.2368 now, and this is 42 minutes. That is 13 degree 42 minutes. So now, and here you have this one as 1 minute. So 1 minute, this is 3. So if you add 3 to this, you have 173.2.0. So you have 0.2371. So this is exactly. So now that means we're adding 1 minute to this. So if you add 1 minute, it becomes 13 degree 43 minutes. So this is it. So now let's go back to the problem. So that means the theta will now be 13 degree 43 minutes. Now let's change this to degree in decimal. So to change it, you have 43 minutes. Now, since 1 degree is equivalent to 60 minutes, so with this will cancel, this will now divide this. So now you now have 43 minutes divided by 60 minutes. So 43 divided by 15 minutes, we have 0. About 0. We have about 0.71666. Okay, continuous. Now that means this should be 13.72 degree. Now we'll now look at the value of x, angle x, where sine, that is the sine function is equal to negative. So where sine function is equal to negative is at the third quadrant, which has a reference of 180 plus theta. So you have 180 plus what? Theta. So we've gotten theta to be this, which is 180 plus 13.72. So this will give us 193.72 degree. So this is the first one. The second one, so it's also negative at this quadrant. So at this quadrant, you now have a reference angle. Now here is the theta, the acute angle theta. So now from here to here will now be, here is 360. From here to here will now be 360 minus theta. So that is the reference angle. So now that means the second solution should be 360 minus theta. So the second angle where sine is negative is 360 minus theta. So this will give us, this will be equal to now 360 minus 13.72. That will give you, that will give us about, okay, should be 346.28 degree. So this is the two angles. So now that means x is equal to 193.72 degree or 346.28 degree. And the next question, which is the B question, the B question is saying that cos x is equal to 0.1753. Now, if you check, this is positive. So where cos is positive at the first quadrant and it's also positive at the fourth quadrant. So this the reference angle here is theta at the first quadrant. At the fourth quadrant, the reference angle is 360 minus theta. So let's begin now. Let's look for theta. Now let cos theta be equal to 0.1753. So now theta will now be the cos inverse of 0.1753. Now what we're going to do, we'll look for theta. If we get theta, then that means theta will now be, that means x now will now be equal to theta or 360 minus theta. So now let's look for theta. Then before we apply this, because cos is positive at the first quadrant, which the reference angle is theta, and also positive at the fourth quadrant, and the reference angle is 360 minus theta. So let's look at theta. Let's look for theta now. Let's go to the table. Let's go to the table, the log table. So on the log table, we're looking for the cosine. Now we're going to be looking for 0.1753 on the cosine table. Now here you have 1 begins to decrease, so that means it will be on the next page. Now here you have 0.1, this is 173, okay, so it should be here. This is 0.771, okay, this is 0.1754, so this is it. So it's here, you can assume everything is here. So here is 0.1754. So which means that the angle should be 79 point what? 79 point, okay, 0.9. We'll choose this. Since everything will find the value inside here, we didn't consider the mean difference. So we're not going to use the minutes. We're going to use this. I didn't even we're going to consider the mean difference inside this place. Then we're going to use a minute. But since we're not considering that, we're going to use only this. So now the angle is what? 79.9 degree. Although the problem is 0.1753, so the error is not much. So this is it, angle. Now let's go to the problem now. That means the theta, which is 79.9 degree. So that means if you put it, that means x will now be 79.9 degree, or 36 minus 79.9 degree. This will give us what? 280.1 degrees. So this is the answers for x. Now let's look at the C part of the question. So we see, we said find x when you have tan x equal to what? Minus 1.125. Now looking at this graph, at the first quadrant all is positive. Now tan is negative at the second quadrant and also negative at the fourth quadrant. So tan is negative here, tan is also negative here. So we're considering only this index. So now the reference angle here is 180 minus theta, where here is theta. And then here is theta. Then the reference angle for this one is 360 minus theta. Now let's say let tan theta be equal to 1.125. Now theta will now be tan inverse of 1.125. Now let's look for inverse of tan in the table. So we have 1.125. So let's go there. Let's go to the table. Now on the table you have, okay, this is a tan table. This is cosine table. Now let's go to the tangent table, natural tangent table. So now we are looking for 1 point. This at this point you have, this one is our 0 point. So let's look for one. Okay, we have gotten to 1.0. Now you have, what we're looking for is 1.12. So 1.12 should be along this place now. Okay, now we're looking for 1.125. Now you have, between this place and this place, you have this place, you have 1.1224, and here you have 1.1263. So this one is more than it. So the value is between this and this. So that means at the point where you have 1.1224, that is at 48 degree 18 minutes. 48 degree 18 minutes. So at this point, since it is in between since the value, we didn't get it directly inside this chart here, inside this data here. So now that means we're going to use the minutes, this minute part, so that we're going to consider the mean difference. So looking at this, what are the values that we can add to 0.1224 to give us 0.125? 1.1225 to give us 1.1225. Okay. Now, when you look at the difference parts, the value, if you add 20, it will not give you, it will not amount to that. 20 will give you 1.1244. Now, if we add 27, what will 27 give us? 27 will give us, if you add 27 will give us 1521.1. So this is closer. So that means the 27 is this. That means we'll have 4 minutes added to the 18 minutes. So 18 minutes plus 4 minutes will give you 22 minutes. So that means the angle is 48 degree 22 minutes. So that's what we get. So now let's go back to the table. That means theta now will now be equal to 48 minus 22, 48 degree 22 minutes. So and now for us to convert this 22 minutes to degree, we say 22 minutes times 1 degree divided by 60 minutes. So this is 22 divided by 60. Now this will give us roughly 0.3667. So that means the angle is 48.37 degrees. Now, where tan is negative, so x1, the first one is at the second quadrant, which is 180 minus theta. So 180 minus 48.37, that will give us roughly 131.63 degree. Then the second one, the second one should be this, which is at the fourth quadrant. That is where tan is also negative. You have 360 minus theta. 360 minus 48.37. That will give us roughly to be 311.63. So that means x is equal to 131.63 or 311.63 degree. So that is the C. Then D. The D is cos x equal to minus 0.5123. Now we will now select cos theta be equal to 0.5123. Theta will now be equal to cos inverse of 0.5123. Now let's look at the quadrant. The first quadrant, all is positive. The second quadrant, only sine. At the third quadrant, tan is cos positive. At the fourth quadrant is cos. So this question shows that cos is negative. So cos is negative here and here. So the reference angle for this is what? 180 minus theta. The reference angle for this other one is 180 plus theta. So now let's search for this. Now, so now we have 0.5123. Let's look at the table. Now in the table for cos, that is cos 0.5123. 5123. So let's look for 51. Now you have 5123. This, okay, 5123 is here, around here, between this and this. You have this is 5120. Then this one is 5105. So it's actually in between this and this, not this. In between this and this, that is where it is. So that means it should be on, so it should be 59 degree. Since it's in between these two lines, so it's 59 degree 12. It's 59 degree 12 minutes. Now we are going to consider the mean difference. So what is the mean difference to make it 0.5123? It's just only 3 that we needed to add, which is because already is 0.5120 at 12 minutes. So that means at 1 minute is 3. So if we add 3 here now to be the same with this, that is 0.5120 plus 0.0003. This is 1 minute. This is 59. This is 59 degree 12 minutes. So you add this 1 minute, you have 59 degree 13 minutes. So that means so that means so that means this is the angle theta. So let's go back. So this angle theta is 59 is 59 degree 13 minutes. 59 degree 13 minutes. Now to change 13 minutes to decimal degree, you have 13 minutes times 1 degree divided by 60, which is 13 minutes divided by 60 minutes. So this will roughly give us 0.216667. So that means 59 degree 13 minutes is 59.22 degrees, roughly 59.22 degrees. So now since for the first one, since cos is negative at the second quadrant, which is 180 minus theta, this will now be equal to, so 180 minus 59.22, this will give us minus 59. This will roughly give us 120.78 degree. Now for the second one, you have 180 plus theta. So 180 plus theta will roughly give us 239.22 degrees. So this is the final answer. That means x is equal to 120.78 degree or 239.22 degree. So this is the end of this video.